Flat earther exploring the plane said, "It's impossible to model this on a flat Earth because we have no model or math." But at the same time, there is a model being used in the flat Earth community, and it is based on water levels. One of the biggest proponents of this model is Bev from Try Thinking. Here is his video called "The Water Level is a Horizontal Plane." So Bev says that this diagram right here represents reality, but according to him, this graphic here is imaginometry. So exactly what is his evidence? Well, if you go to his channel, you're going to hear a lot of talk about geometry, because he thinks Euclidean geometry proves that he is correct. Of course, he will also do some cherry picking. Down here, he has highlighted some definitions of level to back his claims. And for some reason, he did not include this definition from the same source, having no part higher than another conforming to the curvature of the liquid parts of the Earth's surface. So Bev and I both agree that surveying instruments will measure a horizontal line that is 90 degrees or perpendicular to the vertical line. And that horizontal line would actually be part of the horizontal plane. So if you look through the instruments and the crosshairs, you would have the vertical line here, and this would represent the horizontal plane. So this is the flat Earth hypothesis. Bev says that if you have a series of water levels, each one will be at the exact same elevation based on mean sea level. Therefore, if the Earth is flat, a level line intersecting these water levels would be a perfectly straight line. And I agree with Bev. If the Earth is flat, this is what we would see. Now, the globe hypothesis is based on the exact same idea. All of these water levels are at the exact same elevation above mean sea level. The only difference is that since the globe is a curved surface, this level line is also a curved line. So the difference between the two models is when you compare a level line to a horizontal line. So on a flat Earth, both a horizontal line and a level line are straight lines. Now in this case, if you had your surveying equipment set up at the same elevation as these water levels, what you would see in the viewfinder is that all of the water levels would be aligned with that horizontal plane. But on a globe, you would see those water levels curving down from that horizontal plane, and that is because a level line is a curved line. Now here is another key point that Bev makes that I agree with. The geometry is the key. Parallel lines don't intersect. So here's an example on a flat Earth. I drew a level line both above and below the 1,000-foot horizontal line. Now both of these level lines would appear to converge towards the horizontal line due to perspective, but as Bev says, parallel lines don't intersect. So we would never see this 2,000-foot level line intersect and cross below the 1,000-foot horizontal line. But it's a complete different story on the globe. Now, since this 2,000-foot level line curves downward from the location of the instrument with enough distance, it can intersect and go below this 1,000-foot horizontal line. Now, Bev has literally talked for months claiming that Euclidean geometry proves he is correct, but what he has never provided is any real-world measured evidence to back his claims. Now, I'm going to use this video by exploring the plane that was promoted on Bev's channel and show you that evidence actually supports the globe. Exploring the plane saw this photograph by Stephen Cheatley and went out to the same area to see if he could duplicate this. And he did a good job. Here is Exploring the Plane's photograph. Now, those of you that follow my channel know that I already analyzed this photograph, but in that case I used angular size measurements. And in this case I am going to use a completely different method. Since exploring the plane's eye level was 940 feet, I'm going to do this analysis based on a 940-foot horizontal line and a 940-foot level line. I'm also going to use water levels in my graphics to help flat earthers understand how these measurements work. Now, if exploring the plane had an auto level set up at 940 feet at its location, and we were able to string a series of water levels off into the distance at the same elevation, on a flat Earth, this is what he would see in the viewfinder. The water levels would be aligned with the horizontal plane. But in reality, we don't need the auto level and we don't need the water levels. All we need to do is understand the difference between a level line on a globe and a flat Earth. If the Earth is flat, all of the 940-foot elevations in that photograph should be in alignment. But of course, we would see something completely different on a globe. Those 940-foot elevations will be curving down as they get farther away from exploring the plane's position. So where is the 940-foot horizontal line in this photograph? So here is 2,037-foot tall Snaefell, which is the highest peak on the Isle of Man. Now, if we were able to string a water level from the top of Snaefell all the way over to above exploring the plane's position over here, according to Bev, the line that intersected both of these would be a straight parallel line 2,037 feet above mean sea level on a flat Earth. Now, if we did the same thing with a 940-foot water level starting at exploring the plane's position, and we strung it all the way over to Snaefell, we see that it would intersect Snaefell at 940 feet. So using Snaefell as a guide on a flat Earth and assuming that we are seeing all of the Isle of Man, this would be the estimated height of a 940-foot horizontal line. Of course, there is a little problem here. This is 518-foot Blackpool Tower. It sits on land that's about 30 feet in elevation for a total of 548 feet. How could this be higher than 940 feet? And also, these turbines in the distance with their blades straight up like this one have a total height of 492 feet. And we can see that even the hubs at 295 feet are above this 940-foot horizontal line. So here's the 500-foot level line. Blackpool Tower is a little bit higher and the wind turbines are a little bit lower. So let's add two more water levels to this 940-foot line here. We have one above Blackpool Tower and one above the turbines. So again, the total height of Blackpool Tower is about 548 feet. So I'm going to use this scale cutout on top of Blackpool Tower. That gives me a total height of about 1,100 feet. So at Blackpool Tower's location, I could make an estimation that 940 feet is somewhere up here. Next, we'll go to the turbines. Remember, when that blade is straight up, that's about 492 feet. And two turbines in height is just under 1,000 feet. So what that means is that this location here where the turbines are, 940 feet is about right here. Now remember, according to Bev, if the Earth was flat, then all of these water levels would be in alignment. And it is quite obvious that this is not even close to what we see in this photograph. But it is definitely a good match for the globe model. Now, I had already done an analysis on this photograph using angular size calculations. Now, on my previous analysis of this photograph, I showed that exploring the plane's own graphic showed that about 1,400 feet of this island is hidden by curvature. So in this photograph, 940 feet is about right in here. So 940 feet at the Isle of Man is actually well below the horizon. Now, even though I've only made very rough estimations of the elevation of 940 feet at all three of these locations, they are so far off from what we would expect to see on a flat Earth, we can only come to one conclusion. This is more strong evidence that this photograph supports the globe model. So I have used two different methods to analyze this photograph, and in both cases, the flat Earth wasn't even close to explaining what we see, yet in both cases, this matches what we would expect to see on a globe. Now I can already hear flat earthers crying out, what about perspective? Well, right up here, we see a perspective graphic on Bev's channel. And like every other perspective graphic used by flat earthers, parallel lines converge down to the horizon from above, and they converge up to the horizon from below, and they meet at the vanishing point. And this is what we see in reality. Now, I took this photograph and it was quite easy to find the horizontal line because it went through this building perfectly horizontal to this picture. And as you can see, all of these lines from up above are converging down to the horizon line. And of course, all of these lines down below are converging up to the horizon line. And if we had a row of these buildings in line on a flat Earth, as they headed off into the distance, they would get proportionally smaller from the top and the bottom until they finally disappeared at the horizon line. And as Bev correctly says, geometry is the key. Parallel lines don't intersect, so they cannot cross each other. So if the Earth was flat, Snaefell could only converge down to the 940-foot horizontal line, and it most certainly could not be seen below 518-foot Blackpool Tower. But again, on a globe, it is possible for a level line that is higher than a horizontal line to eventually cross that horizontal line in the distance. This is more strong evidence that this photograph supports the globe model.